We're going to do the notes on powers of 10. Powers of 10. So what that means, when you think of a power is an exponent. I'll zoom in here a little bit for you. So a power is an exponent. So if I look at the powers of 10 here, I'm going to highlight my exponents. That's what I'm talking about with these powers. Okay, powers of 10. 10 to the 5th power. When you see a power, that tells you how many times you're multiplying that number. For example, if I have 2 to the 2nd, that really means 2 times 2. So when I have 10 to the 5th, that means I need 10 times 10 times 10 times 10 times 10. I need 5 of those 10s. And we're going to use the dot instead of the x, because we're really trying to move away from using the x for multiplication, since you're going to see it in equations. It can get really confusing if you use it for multiplication and it's a variable in your equation. So we're going to use the dot. So this is 10 times 10 times 10 times 10 times 10. And that is the product of factors, or the expanded form. So product, the answer to a multiplication problem, of the factors. So what numbers I multiply together to get 10 to the 5th. My standard form would then be 100,000. 100,000. Now if you notice here, my exponent's a 5. There are 5 10s, and there are 5 zeros on this number. Keep that in mind as we do the next one. 10 to the 4th. So this time I need 4 10s. And when I write this one, it's 10,000. Again, exponent of 4, 4 10s, 4 zeros. Let's do 3. Look at that. Again, 3 10s, 3 zeros with an exponent of 3. An exponent of 3. So let's do the next two. 10 to the 2nd, I would have 10 times 10, which is 100. And 10 to the 1st, 110, which is just 10. Now let's talk about the patterns that we see here, because there are definitely some patterns in this chart. So as I look at this, I did notice that the exponent tells me how many 10s are in the expanded form, or product of factors, and the exponent tells me how many zeros go on this standard form. So I'm going to write that. The exponent equals the number of 10s and the number of zeros. So the exponent is telling me the number of 10s I need and the number of zeros. I think that's a little bit easier to see. I just hit my autofocus. Okay, another thing I notice here, what do we notice as we decrease? So as my exponent's decreasing, what's happening to these numbers? They are decreasing, but by a certain commonality here. So if I look at this, this is dividing by 10. So when I go from 100,000 to 10,000, I've taken away a 0. That's dividing by 10. So it's the similar idea that if I have 100 and I divide it by 10, I'm really just taking away zeros. 10 over 1 would give me 10. So dividing by 10 each time means I'm just taking away one of those zeros. Okay? So as the exponents decrease, divide by 10. Okay, so we're dividing by 10 each time. Dividing by 10 each time. So let's look at the next one. So with these patterns that we've noticed, what would 10 to the 6th be? So again, I'm going to highlight that exponent, because that exponent is going to tell me how many zeros I need after the 1. So this 6 says I need 6 zeros. 1, 2, 3, 4, 5, 6. Remember, we put commas from the right every 3. 1, 2, 3, comma, 1, 2, 3. So 10 to the 6th is 1 million. How about 10 to the 9th? Again, I'm going to highlight that exponent. That tells me how many zeros I need. That says 9 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. And again from the right, 1, 2, 3, comma, 1, 2, 3, comma, 1, 2, 3, comma. So 10 to the 9th is 1 billion. 1 billion. So following the pattern on the chart, what would 10 to the 0 be? 10 to the 0 be? So here I have 10 to the 1st. Okay, but if I decided I was going to do 10 to the 0, I'm just dividing this, again, by 10. 10 divided by 10 is 1. It's 1. 10 to the 0 is 1. Now, if we think about it, that should make sense. Because if I have 10 to the 0, it tells me I need 0 zeros. So if I don't need any zeros, I'm left with just a 1. That's all that's left. Based on this pattern, what do you predict 10 to the negative 1 would be? So again, this number would be dividing by 10. So 1 divided by 10, I could write it like that, as 1/10, remembering that this fraction bar means to divide. Or I could write it as a decimal, 1/10. All right, let's flip over to the back and look at some negative powers of 10. All right, so same type of chart here. Same type of chart. We've got powers of 10, so I'm going to get my exponents. We again have products of factors in that expanded form. And then we have the actual product. So that's the answer here, is a fraction and a decimal. So we just said 10 to the 0 is 1. So the fraction for 1 is just 1 whole, and the decimal is simply 1. Now again, we're dividing by 10 each time, same pattern. As my exponents get smaller and smaller. So 1 divided by 10, 1/10. My fraction here is 1/10, and my decimal is 1/10. Now this column right here is a little bit different. This is the column where you write the number as a fraction with a positive exponent. So when I take this exponent, this negative, if I throw it down in the denominator down here, it becomes positive. And you'll see that as soon as I do the next one, it'll make a little bit more sense here. So the next one, I've got 1 over 10 times 1 over 10. It's the same type of pattern that we followed on the front of this sheet, but now they're just 1/10 instead of whole number 10. So over here I have 1 over 10 to the 2nd power, positive exponent, and we know 10 to the 2nd power was 100. Okay, so you can write it as a fraction with a positive exponent or as a whole fraction, and now I would need 1/100th. And if you notice here, again, my exponents are dictating how many things I need. The exponent tells me how many factors I need. I need 1/10 here, I need 2 here. It tells me how many zeros I need in the denominator of the fraction, this one having 1, this one having 2, and how many zeros in my decimal. So again, that pattern is really helpful. So the next one, I'm going to divide by 10 again here. Just keeping my pattern going. This one should have 3 1/10ths. This is 1 over 10 to the positive 3rd. And 1 over 1,000. And 1 1,000th. That's how it works. So let's do the next two. Ten 1/10ths. 10 times 1/10 times 1/10 times 1/10. So that's 1 over 10 to the positive 4th. I know 10 to the 4th, I need 4 zeros. 1, 2, 3, 4. 1 over 10,000. And I need 4 zeros in my decimal. Now watch how I write this, because it's really important if you're going to use the trick of how many zeros. So this has 4 zeros. 1, 2, 3, 4. Put my 1. Your decimal has to go after the first 0. So if you want to count your zeros, you got to make sure you put your decimal in the right place. So again, this was dividing by 10, and I'm going to do it one more time. Now I need 5. 1 over 10 to the 5th, 1 over 100,000, and 100,000th. So 1, 2, 3, 4, 5, 1, and there's my decimal. So I'm going to write 10 to the 5th here, just so you can see how it compares. So this is just information that we did on the front. And I said this was 100,000. All right, now I'm going to show you something kind of neat. Look at these decimals, okay? 1, 1/10, 100th, 1,000th, 10,000th. Now look at them. 1, if you ignore the decimals, 10, 100, 1,000, 10,000, 100,000. So if you turn them upside down, they should look the same as what they would be if they were positive. It's kind of cool, right? I'll flip back over here. Let's talk about some patterns. So again, their pattern's going this way. And I would say, again, that the exponent equals the number of those factors of 1/10 and the number of zeros is in the decimal, right? That's a pattern that we see here. That's a really good pattern. It's always decreasing. Okay? The other thing I'm going to put here that's pretty important that we want to remember is what this column means. That column right there. I'm going to draw an arrow down to it and put a little note here. This is the form when you write the number as a fraction with a positive exponent. Okay, so that's writing a number with a fraction as a positive exponent. That's what that means, versus just writing it as a fraction where you'd have that standard form underneath. So when you see that negative, it's bumping the 10 down to the bottom of the fraction. That's really what it's doing. This says bump the 10 down. This says bump 100 down, bumping the 1,000 down. All right? So following our pattern, 10 to the negative 6, we're going to write these as decimals, would have 6 zeros. 1, 2, 3, 4, 5, 6, 1. Put my decimal. That's 1,000,000th. 9 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 1. That is 1,000,000,000th. This last little part here is just stuff we really want to remember. We said 10 to the 0 power was 1. 4 to the 0 power is also 1. 90,000 to the 0 power is 1. 47 to the 0 power is 1. 301 to the 0 power is 1. 6.1112 to the 0 power is also 1. So what that really is reminding us is that anything to the 0 power is 1. Any number to the 0 power is 1. So that should be a really easy freebie when you see something like that, because it's always going to be 1. So again, these were the notes on the powers of 10. You're welcome to watch them again and fill in anything you missed.